Two of the most common applications of gas turbines in modern industries are turbogenerators and turbocompressors. I try to approach a gas turbogenerator, or GTG, to better feel the subject. Turbine power plant, there's a generator, which is an electrical machine. But to generate electricity, this generator needs a prime mover, which, for my example, is a gas turbine. The gas turbine transforms the chemical energy in the fuel, for example natural gas or similar fuel, into mechanical energy. The mechanical energy generated by the turbine exit shaft is then transferred through a gearbox to the generator's shaft. Now, my generator can create electrical energy. This primitive form of electrical energy normally has a low or medium level of voltage, and to better manage the power loss in transmission lines, this voltage should be increased by step-up transformers. Such transformers give an adequate level of voltage to the electrical energy to be transmitted through the transmission lines and delivered to the grid. After this brief overview of a sample gas turbine application, I'm going to dig down into the gas turbine mechanism in more detail. First, imagine a rocket in which some fuel is going to burn and create a high-pressure exhaust gas. Based on energy conservation law, the chemical energy of the fuel is transformed into mechanical energy in the high-pressure exhaust gas. When a rocket is fired, the thrust of this exhaust gas moves the rocket forward. This amount of rocket science is enough for me. And now, suppose I fix the rocket body with a robust mechanical structure to prevent its movement. What will happen? The high-pressure exhaust gas should be released, and it will have no way but backward. Now, keep this structure in mind, and imagine I put a set of turbine blades in the path of this high-pressure backfired exhaust. You see that the release of mechanical energy, which is mostly in a linear backward direction, will mostly transform into a kind of rotational movement of the turbine shaft. And so far I'd say it's a big success. In that, we've transformed the chemical energy of fuel gas into rotational mechanical energy of the turbine shaft. Now, I have a prime mover for my generator in the above power plant example. Also, this prime mover concept can be used in different applications like turbocompressors or the like. Now that I have the basics of gas turbines, let's focus on a modern gas turbine and its components. Most likely, you know about fire triangle or combustion triangle, which illustrates the necessary ingredients of fire or combustion. In other words, fuel, air, and heat. To transform the chemical energy of the fuel gas into mechanical energy, the fuel should be burnt in the combustion chamber of a gas turbine. So I need air and heat added to the fuel. Air is let into the gas turbine through an air intake and mixed with a proper amount of natural gas. The air-gas ratio is determined based on the specific heating value of the gas and quality of the air, amount of moisture, altitude from sea level, and so on. Now, an ignition system steps in and makes the initial sparks, whereby heat is provided. When the fire is established and stabilized in the combustion chamber, the ignition system will be put out of service. The most critical process in normal turbine operation is to manage the combustion and produce a proper amount of high-pressure exhaust gas. This exhaust gas is established and stabilized in the combustion chamber. The ignition system will be put out of service. The most critical process in normal turbine operation is to manage the combustion and produce a proper amount of high-pressure exhaust gas. This exhaust gas is applied to the turbine blades, and after rotating the turbine shaft, conducted to the exhaust stack. With this quick review of key components of a gas turbine, I think it's time to decrease the altitude and elaborate on the system further. As I mentioned earlier, air is let into the gas turbine through an air intake. The air is prone to contamination or having some unwanted particles which can harm the system and degrade the overall performance. The screening and filtration are basic requirements for incoming air. Also, proper instrumentation is mounted on the air duct to monitor the draft pressure and temperature. In harsh environments, the air might need to be preheated or conditioned. Also, differential pressure monitoring of air filters will warn the turbine operator of filter clogging. The conditioned air is conducted into the turbine air compressor, which is an axial compressor comprised of multi-stages of blades mounted radially on the turbine inlet shaft. The discharge pressure and temperature of the air compressor are monitored to manage the combustion quality at the combustion chamber. Fuel gas is a key factor in the design and operation of a gas turbine. The manufacturers need to know the details of fuel gas, and only based on its characteristics can they guarantee the performance of their gas turbines. Also, the pressure and temperature of fuel gas are monitored during normal operation of a gas turbine. There are different technologies in properly mixing the air and gas and making efficient combustion from manufacturer to manufacturer. Combustion chambers are of some tubular heat-resistant structures, and fuel is usually injected into it from the circumference and at different cross-sectional locations. The temperatures at different locations of the combustion chamber are thoroughly monitored by means of proper sensors like thermocouples. This high-temperature, high-pressure zone in a gas turbine structure is of the highest levels of importance to monitor and control. Also, the technologies used in the design and construction of the combustion chamber are of the topmost ones. Now that the air-gas mixing is well managed and combustion is going on properly, there is plenty of high-pressure, high-temperature exhaust gas generated and should be applied to the gas turbine blades to make turbine exit shaft rotation feasible. At this stage, the high RPM of the gas turbine rotor should be tightly monitored, and based on the load driven by the turbine, the surge of turbine gets the topmost importance for turbine performance and turbine protection. Vibrations, axial and radial, and speeds, both at the air compressor and gas turbine, should be continuously taken into consideration. This was the simplest way to address major parts of gas turbines, and as one of the most sophisticated man-made machines, a gas turbine deserves more elaboration. Also, there are different technologies which some manufacturers use as their proprietary technology, and were not considered in this video. Want to learn PLC programming in an easy-to-understand format and take your career to the next level?